Hey guys, here we are diving into ocean pollution. 20.4 ocean pollution. Now, obviously the ocean covers most of the planet and most of our pollutants ultimately make it there. So it really is a huge issue and something we truly need to address. Unfortunately, we can't just address it as a country, we have to address it as a planet because all of us tie into it. It's all connected. Now, most of the pollution in the ocean actually originates on land. A percentage of it is happening from things in the ocean, whether it's boats dumping stuff over, cruise lines dumping waste, whatever the case may be, but most of it is originating on land and making its way to the sea, if you will. We have oil and then just other toxic chemicals. Then there's solid waste. Plastics are just a huge one, but anything solid that makes its way into the ocean causing a problem. And these things are threats to the fish and the wildlife there. It's disrupting various ecosystems, and once again, we realize once you begin disrupting an ecosystem, it affects that entire food chain, everything in the region there. Now, the key is to protect the oceans. We've got to reduce the pollution flow from the land and the air into our streams, which ultimately dump it into the ocean. Because whenever we're putting pollutants up into the air, they eventually settle down. And even if they're settling down on the land, then the rain falls, washes it into streams, washes it out to sea. And a lot of it's just falling directly into the ocean, right? 71% of our world is covered by ocean, so whenever you have pollutants, a lot of it is just filtering and drifting directly down onto the ocean floor. In less developed countries, it is estimated that 80 to 90% of their municipal sewage, okay, this is just human waste, if you will. You flush the toilet, it goes down the drain, 80 to 90% of that is going directly into the ocean, no treatment. All right, it's just going down the toilet into a pipe, and the pipe is being directed directly to the ocean where it's dumping into it, 80 to 90%. And once again, where's our population increase? Most of our population increase is in the less developed world. It's where our greatest population sources are. So it is a huge problem. You can't say, well, it's just those less developed countries. They make up a majority of the population, so it becomes a huge issue. This basic waste being dumped right into the ocean, well, it overwhelms these coastal waters, their ability to degrade the waste. Now, the ocean is good at it. There's bacteria in it, fish, various things. Any of this biodegradable waste does eventually get broken down, but it gets overloaded too much. If this waste actually makes it into the deeper ocean waters, it doesn't cause as much problem. It actually has a chance to get diluted, it disperses out. We don't have as much life, ecosystems out in the deep ocean, and it therefore degrades. There's been some aspect of saying that we'd probably be better off to dump it there than burying it here. There's discrepancy with this because we're unsure. But the bottom line, we're dumping it in the coastal waters, which is typically what we're doing, because we're not going to build a pipe 50 miles out to sea. It's just dumping right in the coastal waters, right where we are, and this is where most of the ocean life is. It's causing an issue. Now, in the U.S. coastal waters, I'll stick a diagram up here to show some of what happens with us. We're pretty good about cleaning up our water before dumping it directly into the ocean. However, we still get raw sewage making its way in, whether it's from animals and sometimes CAFOs. We just get breaches where they're storing their waste tanks. They get overwhelmed sometimes. We have sewage leaks. Our sewer lines break from time to time, or the sewer lines have a leak, or a little bit dripping out where a joint is, and this makes its way into the ocean. So we still have raw sewage getting in, it's just not 80 to 90%. Agricultural runoff, and once again, agricultural comes along with some of the animals, okay, the CAFOs, but a lot of this is just going to be fertilizer, so it's going to be nitrates and phosphates largely making its way in, which contributes to the algal blooms. And these then make the oxygen depleted zones. Like we talked about in the case study earlier, these dead zones, especially the one that we get in the Gulf. So back to the one in the Gulf. Now once again, it's the Mississippi River Basin, right? 2/3 of the country is dumping into it, and it's the levels of nitrates that come in. It tends to be seasonal during the summer. Spring, summer, when most of the runoff occurs and most of the nutrients come in, it's also when we start doing most of our fertilizing. And this causes our severe depletion of oxygen, and we wind up getting the dead zone. And it's a huge food web disruption. Now, if it's something down here, because this tends to happen on the bottom of the ocean there, if it happens there, if those things can't get away, like clams and mussels, anything that is actually a sessile organism, it attaches to the rock, well, they can't leave and they die. And some of the slower moving creatures can't get away from it, they die. The faster moving ones move out to oxygen-rich areas, but the whole area gets vacated. Some things die, other things just leave, and we have a huge issue. And there's also deaths from seabirds, mammal species that depend on these fish and shellfish. They're coming in here and then there's no food there. Big disruption to it. Another thing that occurs from just our trash making it into the ocean is the case study about the ocean garbage patches. All right, guys, there is no away. We say we're going to throw it away. Well, where's away? Away, you say, is just not here at my house, right? We're throwing it away. It's going to the landfill. We have to get into our heads. There's no away. We're just putting it in another place on the planet. And unfortunately, a lot of times these things make their way to the ocean. The picture up here is showing, it's not a picture, more of a diagram, because it's hard to actually film this, but it's the North Pacific garbage patch. There's actually 2 of them in these huge rotating gyres. Remember the way the ocean currents flow? We get these huge gyres, and the whole ocean is, and in the middle of that is a garbage patch. It is plastics by and large, anything that floats, and a lot of it is just below the surface. So it's not like you go and you see all of it sitting on the surface. A lot of it is just below the surface, rotating round and around and around. 80% of this trash actually comes from the land. We have 2 of them in the Pacific, and we found another 5 in the other oceans around the world. Anywhere where these coastal current or the ocean currents circulate the water, it just swells around, and it's just a huge garbage heap, if you will. All this plastic, these tiny plastics are really harmful to the wildlife. And there's no practical way to clean it up. It's been estimated if we sent a fleet of ships out there working 24/7, it'd take like 1,000 ships scooping and filtering the water for like 30 years to clean it up. And then where do we go with it? And once again, if we don't prevent it occurring, it's just going to keep on going forever and ever and ever. So what is our best approach? Prevention. We have got to reduce the production of solid waste. We have this throwaway culture these days. We have it, we use it, and we throw it away. Remember, there is no away. Get used to recycling and reusing things as much as possible. Because once we toss it in the bin, winds up in a landfill, and a lot of times things that make it into our landfill still eventually make it out to sea, floods, storms, you name it. Let's talk oil pollution. The ocean is vast, and we wind up getting a lot of pollution in it from oil. Refined oil, crude oil, you name it. Now, it comes from both natural sources and from human activities. A lot of oil is, oil's under the ground, right? It's out under the ocean, and there's some cracks, and some of it just naturally seeps up out of the ground into the ocean. Just like some air pollution is natural, like a forest fire, a volcano, there's always natural and man-made causes. But it is the urban and industrial runoff from land that is the largest source of oil pollution. We tend to look at these big, prominent accidents, if you will. The Exxon Valdez in 1989, the 2010 BP Deepwater Horizon. There was one recently in the Mauritius Islands of a Japanese tanker. We tend to focus on those, and they're bad. But most of the runoff is actually coming from land. They're little spills, okay? It's my car leaking a bit. It's the parking lots. Everywhere where people go, we put a little bit of gas in. I put it in my lawnmower, some spills out. Some people pour their oil out like down in the bushes or something because they don't want to take it to a recycle place. All of this, ultimately it rains, oil's lighter than water, it floats on the water, runs down the drain into our oceans ultimately. Now, volatile organic hydrocarbons, like VOCs, okay, volatile organic compounds, these things tend to kill aquatic organisms. Once again, oil, if it's the crude oil, some things can handle that to a degree. But a lot of these higher processed things, they make their way in and they are deadly to the organisms that are there. Now when we get an oil leak, the BP or a big tanker crashes, cracks open, and all the oil comes pouring out. We wind up getting these tar-like globs up on the ocean's surface. And that's what we see in the pictures like this, where the animals get coated in their fur and in their feathers. And animals drown because of this. And a lot of times they die because of loss of body heat. It interferes with their natural ability to keep warm in the cold water, and they die. So we have a lot of cleanup efforts, and a lot of times we're literally trying to scrub off these animals to save them, if at all possible. Now, some of the really heavy oil components sink to the ground, or the bottom of the ocean, if you will. And these things will smother bottom-dwelling organisms, clams, any kind of sessile, again, whether it's all of our filter feeders who are attaching at the bottom, the stuff sits down, coats them, clogs up everything they're trying to eat with, and they die as well. We tend to have faster recovery of an oil spill in warm water with rapid currents. Cold, calm waters can take decades. So once again, we're in a warm area, there's a lot of active life and the currents are moving, it disperses it, and nature will take care of even a pretty big spill. But if it's cold area and it's calmer, like in a bay, it can take a long time. The Exxon Valdez was up in cold and calm region, and it was a long time for cleanup and for that area to really be healthy once again. Current cleanup methods, how do we go about it? Well, even with all of our methods, we put out these, we try and scoop it up, we'll put big barriers, pull it in, we'll throw things out to soak up the oil and remove them, we'll burn some of it off. We have all kinds of methods that we go after, but still, no matter what, after a spill, we can only get about 15% of it cleaned up using all of these actions, if you will. And we're doing what we can to prevent. The Exxon Valdez back in 1989, well, that led to a law where by 2015, every oil tanker coming into US waters had to have a double hull. So if they did crash or run into something, the outer hull would break, but it wouldn't damage where the oil was. And this was a good thing. We're beginning to do things to come up with prevention. Can we do things to ensure that these accidents don't occur, or at least we can minimize the ability at all? We mentioned the deepwater oil rig spill. Let's go ahead and dive into that one. It's a case study in the book. Encourage you to go through and read it, but let's look at it real quickly. You can see the picture of them back here of them trying to keep it under control. The thing blew up, if you will. Had multiple problems involved with it. Ultimately, gas pockets came up and it blew up on the top, caught fire as they're trying to put it out. The well at the bottom, this thing was a mile deep in the ocean where it connected, and then it was drilling another several kilometers below the surface to get to the oil well. Well, this broke off and the oil just began pouring and rushing up into the Gulf. The top rig was on fire. After 36 hours of working with it, it sunk into the sea. This thing, over a period of time, released 3.1 million barrels of crude oil before they were able to successfully cap it. I was teaching at Hawthorne when this occurred, and I put it up on the screen in a little corner. You had a live feed of the oil pouring out. And it was just unbelievable to think that that much oil was just pouring out every second of every day that this was going on, until they eventually capped it. Well, it contaminated vast areas of coastline. Something like 1,300 kilometers of coastline were affected. From Florida, Mississippi, Louisiana, and into Texas, all had issues from oil making it into the coastlines, damaging the shelling and fishing industry tremendously. But because of this, once again, the government developed a lot of new standards for offshore drilling procedures. Unfortunately, many of them have not actually been followed through on. We come up with these things, but then we are short-sighted, we tend to forget about it, and even though we put some laws on the book, we don't really enforce them. And enforcement is about 90% of the law in reality, because if it comes down to it, and nobody's going to actually come slap you on the wrist for it, you're going to do it anyway. We have rules, we have laws, but if there's nobody actually enforcing them, they don't actually occur. Guys, that wraps us up for ocean pollution. Come back next time and we'll talk more in depth about just water pollution solutions. What can we do about it? Take care. See you next time.